So, welcome to one of the final sessions of the day. I will be mainly talking about native language identification and authorship attribution and the relationship between those two tasks. The work was done in collaboration between University of Zurich and Product, a Swiss cybersecurity company. So, authorship analysis, there are multiple sublines you can investigate, but basically the task is given an anonymous text. Can you identify the original author behind this text? Or you can formulate the same question as a binary task where you have a known author list and your task would be to confirm if a piece of text was written by a known author. Or you can do authorship profiling, which would mean that you are trying to learn characteristics of the author from the text. This can mean age, education, religious background, political affiliation, and this is used in many different subfields: digital humanities, forensic linguistics, cybercrime, and plagiarism detection. So native language identification can be seen as a form of authorship profiling. You're learning something about the author. And the goal in this case would be to identify the native language of the author given a text in another language. And most of the time it is the language in L2, so the secondary language. And the underlying hypothesis is that the native language has some sort of influence in your secondary language. So you are expected to make some mistakes, or you are expected to transfer some of the characteristics from your native language. So there has been many different linguistic features in this task. Spelling errors, as you can expect, you probably have done them before when in your daily life, and then you realized you're transferring some spelling features from your native language. In this case, there is the example of Romanized verbs from Italian, for example, prepara. And then if you have an character level engram, or if you have a misspelling feature extraction of some sort, you would be able to pick up these cues. Function word engrams, part of speech, stand for dependencies. So the first task when native language identification was in 2013. So it's almost 10 years now that many people from different fields have worked on this task, and then they have been able to capture it with different type of approaches. So context-free grammar rules, you can see how different phrases are created, or how different linguistic structures are created in different native language. In some cases, for example, in German, it's very heavy in compound nouns. So you could expect it that in English, they would also transfer those structures. So here's one example. Syntactic engrams are used to capture syntactic dependency in the sentence. And then it can also allow you to capture different linguistic anomalies. In this case, I have an example from a threat letter someone received, and then the native language was thought to be Russian in this case. And then the letter said, "You started pulling time and making us brains." And the investigators were very confused about this message. But once you already have seen similar text, or you're working with a native language expert, then you can clearly see that there are some direct translations in the text that pulling time would be like wasting time, and then making someone's brains would be the equivalent of screwing someone over. So if you compare this kind of direct translations, or this kind of novelties in someone's English writing, then you would be able to compare it overall with other native language backgrounds, and then you can learn these anomalies basically. So related work, in this case, most of these features, they were mainly extracted from TOEFL 11. It's a native language corpus. So it is based on the English exam, where students are writing essays about different topics, and there are 1,100 essays in total for 11 different languages. for each language, we have 1,100 essays, and then we have 12K essays in total. So the main idea would be that given these linguistic features, can we learn a model that can predict the final classification? And the best approaches in this task was different classifiers put on top of each other, and then each of them can learn a different linguistic feature, or you can also weight between them. So some of the classifiers may be more discriminating than the others. So also 2 years ago, I published a paper here again. I was presenting it, and then I was looking into ways that if it would be possible to learn a model without any feature engineering. In this case, we showed that it was possible to train a GPT-2 model for each language background, and then the model surprisal could be used for predicting the final classification, and then it achieved considerably successful results. But this year's task, we were investigating the new models that are recently released. So if you look at it, the GPT-4 Cloud or Llama 3 nowadays, that you can see that they are crashing most of the benchmarks available out there. So we were wondering how it will be scaling to native language identification. And Zhang, a couple months ago, already benchmarked GPT-4 in native language identification in the TOEFL dataset. And then they had a very simplistic prompt where you are telling the native language model that you're telling the large language model that you are a forensic linguistics expert. And then you are trying to identify the person's native language by looking at direct translations, spelling errors, and syntactic patterns. So if you look at the benchmark results, then 2 years ago, our approach was able to get around 89% and 84%. Now, without learning any examples or looking at any without any training, you can just zero shot your way through state-of-the-art performance, which is a very emergent behavior, I would say, but also at the same time, I was very skeptical about these results. So we were investigating if this performance could be transferred to another data set. So were you be able to replicate the results in a different domain? And we created a new data set based on different native languages, 5 different native languages, and then we scraped it based on language learning subreddits on Reddit, where people already self-identify with their native language. And the goal of this task was to just create a data set where we have the native language information available, but we also have some authorship information available, so we can investigate both tasks in one data set. This is an example analysis where we were looking at some texts in the politics subsection of Reddit, but we already identified the person from the language learning subreddit. So we were looking if we can predict the text written in a different subreddit, and GPT-4 in this case was able to identify it correctly and calling the author Turkish native speaker. And if you look at it, you can see that there are direct detection of direct translations, which is very impressive, and the model can also analyze the syntactic differences. But I already had my doubts, and I started to put together some adversarial examples. And I also realized that most of the time, people are talking about themselves on social media platforms. So there are also a lot of self-revealing information, self-disclosed information. So I started to create this symbolic data set where we were changing all the names and the name entity information, or we were just simply redacting them from the text to see how this would affect the model behavior. And then we realized most of the time that the model is picking up and depending on these cues. So if you have some sort of information in the text that can reveal your native language, the model already picks up on it, and then you can easily manipulate model behavior like this. This is why we think that the TOEFL 11 data set achieves 91% accuracy. So our task was to, if we can eliminate this behavior, because not all of the predictions was based on this kind of surface level analysis. And then COT, chain of thought, and in-context learning is already known to decrease this kind of free text generation. So you can already restrict the model behavior. And then we created a COT approach to see how this would change the model behavior. In the baseline, we had 70% accuracy, which is already lower than the 90% accuracy in the TOEFL benchmark. So you already lose some accuracy because of this domain change. Reddit users are highly proficient in English, at least in the politics subsections. And then once you scrape or once you strip all the name entity information in the text, then the accuracy falls down below 50%. And our main point here was that if you use the COT prompt, you can replicate the same behavior without stripping any name entity information. So you can technically tell the model, hey, do not look at these names or any other revealing information in the text. Just look at the linguistic information and analyze them for me, and then make the final prediction based on these findings. And you can see that's redacting the information. Meanwhile, the main prompt has a very sharp decrease in accuracy. Meanwhile, the COT prompt is not as affected, and then they converge into some level of information, which with some same level of performance, which I think to be the real performance levels for this task instead of 95% accuracy. So returning to the original problem.
We have to wrap it up.
Yep. So returning to the authorship attribution problem, we basically integrate this pipeline into authorship attribution, and then we were looking at the performance improvements, how this can affect the overall process. And then we show that there is a statistically significant improvement in our results, that if you consider someone's native language in your pipeline, it also helps the authorship attribution problem, where when you have the increasing number of authors over time, you start to see more drastic performance improvements. So the conclusion, you can use native language as an additional profiling attribute, such as age, gender, and education. LLMs take shortcuts, so the model can do something completely different than what you tell it to be if they think it's a way to achieve that task. This leads to hallucinations and superficial analysis, and we show that COT prompts can mitigate these tendencies. And we also warn for cautious interpretation of LLM outputs in forensic sciences. And that will be the presentation. Thank you very much.